In this chapter, we study a new class of functions called exponential functions. And the main characteristic that we'll be looking at exponential functions is how quickly the values of these functions increase. For example, let's look at the function 4 raised to the x. We'll go ahead and sketch a graph of this function by plugging in points. Let's plug in the points -2, -1, 0, 1, and 2. Then evaluating our function at each of these points, we'll get the following: 4 raised to the -2, 4 raised to the -1, 4 raised to the 0, 4 raised to the 1, and 4 raised to the 2. Simplifying each of these y values, we'll get the following. And one thing that we can note is that as our x values get larger, our y values get very large. And as our x values get more negative, our y values are getting closer to 0. Now we'll plot our ordered pairs on our xy plane. And we see the shape of our exponential function 4 raised to the x looks like the following. Before we look at the definition of our exponential functions, let's go ahead and note that, again, as x approaches -infinity, our function is approaching 0, and as x approaches infinity, f of x is approaching infinity. Now we can define our exponential function with one key characteristic, and that is the equation. For any real number x, an exponential function is of the following form, where we have that a is a non-zero real number and b is any positive real number such that b is not equal to 1. To highlight some characteristics of an exponential function, let's go ahead and graph one more exponential by looking at ordered pairs. Here we're given the function f of x is equal to 1 divided by 4 raised to the x, and again we're going to put in x values -2, -1, 0, 1, and 2, and evaluate our function at those x values. 1/4 raised to the -2 then is equal to 4 raised to the second, which is equal to 16. 1/4 raised to the -1 is equal to 4 raised to the 1, which is just equivalent to 4. 1/4 raised to the 0 is equal to 1. 1/4 raised to the first is just 1/4. And 1/4 raised to the second is a 1/16. Let's draw the ordered pairs on our xy plane. And again, let's sketch the curve by connecting our ordered pairs. And this time we notice that as x approaches infinity, our f of x is approaching 0. And as x approaches -infinity, f of x approaches infinity. One thing that we can take away from the first graph and our second graph is the following. If b is greater than 1, then f of x, which is equal to b raised to the x, is increasing and looks like the graph from the previous page. And if b is between 0 and 1, then the function f of x, which is equal to b raised to the k, is decreasing and looks like the graph on this page here. Whoops, this should be a b raised to the x. Some other common characteristics about exponential functions are the following. The domain of an exponential is -infinity to infinity. The range of f of x is 0 to infinity if a is greater than 0, and the range of f of x is -infinity to 0 if a is less than 0. And we have that f of x has a horizontal asymptote at y is equal to 0. Let's go ahead and evaluate a few different examples. In this first one, we'll evaluate f of x, which is equal to 5 times 3 raised to the x plus 2, and g of x, which is 8 times 1.2 raised to the x minus 1. Here, we want to evaluate f of x at 2. This is equal to 5 times 3 raised to the 2 plus 2, which simplifies to be 5 times 3 raised to the 4. Plugging 3 raised to the 4 into the calculator, we'll get that this is equal to 5 times 81. And this simplifies to be 405. Now looking at our function g of x, we want to evaluate g of x at 3. So we'll have g evaluated at 3 is equal to 8 times 1.2 raised to the third minus 1, which is equal to 8 times 1.2 raised to the second. Plugging this into a calculator, we'll get that this is equal to 11.52.